GPU is the heart of AI. If you want to understand AI, work in AI, or even just know how all of this actually works, you need to understand GPUs. Almost everything happening in AI today depends on GPUs. How fast models are trained, how powerful they become, and who is able to use AI at scale. Because of that, GPUs are shaping the future, influencing the global competition, and directly affecting the kind of jobs and careers that will grow next. In the last video, we looked at whether AI is a bubble or a boom by going beyond hype and headlines, using 4 practical lenses of efficiency, sustainability, profitability, and regulation. If you missed it, the link is in the description. In this video, we keep it simple. What a GPU is, why AI needs it, and why learning about GPUs can help you grow in your career. Let's rewind a bit. Remember Angry Birds? Birds flying, pigs sitting inside these castles. Why did this game work so well? Because of gravity and physics. You stretch the rubber band, launch the bird, and the castle crumbles. Blocks fall, pigs roll, just like in real world. When a game follows real gravity and real physics, it feels real. And when it feels real, it becomes fun, engaging, and addictive, of course, unfortunately. That's realism. And that fast responsive feedback is what made Angry Birds an instant hit globally. All of this realism in video games, on your phone or on your PC, comes from one component. It's called Graphics Processing Unit or GPU. Phones have GPUs, laptops and PCs have GPUs, sometimes built-in, sometimes as a separate chip you plug in. This GPU is what handles graphics, motion, and real-time physics. It's what makes digital worlds feel real. A GPU is not mandatory. A game can still run without it. But when you add a GPU, look at the difference. The lighting, the reflections, the details down to each pixel. All of this comes from massive calculations happening in real time. How light falls, how it bounces, how objects move when they hit the ground. With a GPU, these calculations happen faster and smoother. Without a GPU, it still works, but you can clearly see the difference. Think about it this way. A GPU exists to handle massive calculations, the gravity, physics, and mathematics in real time. The mathematics behind a video game is the same mathematics behind a space simulation. What changes is the level of accuracy, not the fundamentals. Whether it's a bird hitting a castle or a rocket lifting off, gravity, physics, and the math all are same. GPUs just calculate them fast enough to make it work. Originally, GPUs were built by NVIDIA, who is the inventor of GPUs, and the main purpose was just one thing: to handle the graphics, handle heavy mathematics for video games. But then something important happened. NVIDIA introduced CUDA. CUDA added a software layer on top of GPUs. Now the GPU was no longer limited to video games. The same heavy calculations used in video games could now be used for science, simulations, drug discovery, and even space missions. This changed the GPU from a fixed hardware device into a programmable engine for massive calculations. That's why GPUs today are not just for video games. They are used everywhere. Heavy computation is needed. And if you're a student or a working professional in AI, you must know how CUDA works. Not that you need to work on CUDA, but that is very foundational. In fact, that made the hardware to be more programmable, and the rest is history. Every computer has a CPU, the central processing unit. We all know that. The CPU is built for control. It decides what happens next, handles logic, and manages tasks step by step. A GPU is different. A GPU is built for computation. Instead of doing one thing at a time, it does many calculations in parallel all at once. So think of it this way: CPU controls, GPU computes. CPU also computes, but relatively at much lower scale than what GPU is capable of. And the difference is why GPUs matter so much today, because of the heavy lifting that they do. Let's go one level deeper. We need to know what is a core. A core is a small processing unit inside a chip that can do calculations on its own. A CPU has few powerful cores, like 24 or so. Each core is very smart and handles one task after other. That's why CPUs are great at control, logic, and decision making. A GPU is different. It has thousands of smaller, simpler cores. Each core does a tiny part of the work, but all at the same time. So the idea is simple. CPU is about fewer, smarter cores for control. GPU is about many simple cores for massive parallel computation. That difference changes everything. If CPU is the brain, then GPUs are the muzzle. The interesting thing is, GPUs are not new. CUDA is not new. They have been around for almost 20 years. 2007, that was when GPUs started serving beyond video games. So why did AI suddenly take off recently from 2018 or so? First, the internet exploded. We finally had massive amounts of data to train models, which is very essential for AI. And there are many other landmark developments that happened throughout. But let's fast forward to 2017, where something significant happened. In 2017, Google published a paper called "Attention is All You Need," and this changed everything. Before this, machines struggled to understand human language properly. There were neural networks and natural language processing techniques, but they were limited. This paper introduced a new way for machines to understand the context and meaning in human language. That was the real breakthrough. Because if machines have to become intelligent, they first need to understand how humans communicate. This paper made that possible and it became the backbone of modern AI. Look at this sentence on the screen. GPUs were ready, AI algorithms were not. Transformers finally matched AI to the hardware. Yes, there are spelling mistakes, but you can still read it. Why? Because humans don't read letter by letter, we read using context. The moment the shape of the word and the sentence fits, our brain autocorrects and understands. That's the key idea behind the transformer architecture, an example of sorts. Instead of reading word by word in a strict sequence, it looks at many parts of the sentence at the same time and uses context to figure out meaning. Now connect that back to GPUs. GPUs were built for parallel processing, doing many calculations at once. The hardware was ready almost 2 decades ago, but for years, AI software could not fully use that parallel power. It was still so sequential, too slow and too limited. Transformers changed that. They are naturally parallel friendly. So the story is simple. Hardware was ready long ago and the software finally caught up. And when parallel software met parallel hardware, AI took off. It's as simple as that. So let's come back to the main question. Why is the GPU the heart of AI? AI software can be built anywhere. All you need are smart engineers and good ideas. But hardware doesn't work like that. GPUs are limited, hard to manufacture, and controlled by only few companies like Nvidia, AMD, Intel. That makes GPUs a scarce resource. For years, GPUs were available, but software couldn't fully use them. Now it has flipped. Software is caught up, but the hardware supply is constrained. That's why GPUs matter so much. First, there are 4 things that we need to understand to really break down this question of why GPU is the heart of AI. Number 1, AI progress equals how much GPU compute you can run. More GPUs means faster training, bigger models and better AI, and it's that simple. Second, national power now depends on who controls AI accelerators, which is GPUs of sorts. The US dominates today largely because of the companies like Nvidia. Other countries like China, India, Europe are trying to catch up, but it is not easy. Nvidia did not just make GPUs, they positioned themselves at the center of the AI future that they built with their own hands. Third, the company advantage, that is your company for which you're working, the company advantage comes from who secures and uses GPUs best. It is not about owning GPUs, but about using them efficiently, because AI compute is expensive and limited. When supply is tight, software optimization becomes a competitive edge. And finally, your career standpoint, don't focus only on AI tools and frameworks. Understand how compute works at GPU level. Just like full stack developers emerged years ago, AI now needs people who understand the full stack from chip to chatbot. That's exactly what we will cover in the next video, the full AI stack architecture in very simple terms. And if you would like to receive that content from me, do subscribe to Sensei. To reiterate, focus on 2 things: how companies do more with fewer GPUs and how efficiently they use compute. You don't need to program GPUs, but you must understand how GPU capacity is consumed. That understanding is what helps you break into AI. Let's conclude this video with a question. Which GPU architecture is designed to power modern AI data centers? Option A, Kepler. Option B, Ampere. Option C, Hopper. And option D, Blackwell. Comment your response down in this video and I'll give the heart for the right answer so that everyone knows what is the right answer. For more such simple explainers on AI and tech, do subscribe to Sensei. I'll talk to you soon. And as always, thanks for watching.